Welcome. So we move on to further learning in inverse Laplace transforms. Before we go ahead with the more problems in partial fraction, we need more properties for inverse. So we'll get into the properties. Again, we have the shifting properties. Just look into this shifting property. When you see this says L inverse f of s plus a. Then I have a function in a s plus a form, plus or minus a. I need not bother about the s plus a parameter. I can convert to a s parameter and work on the inverse, and further I can multiply by e power. This is what our Laplace transform told. When it is a e power multiple, just write a function of Laplace of this and then convert the parameter or transform the parameter. The same thing we are working in the reverse version. When you have a s plus a form function, remove that plus a parameter in s, make it as a s parameter, and then go ahead with like you convert this s plus a parameter as s parameter by writing a exponential minus 80. Because it is plus a, I have written minus a. It's opposite sign, whatever is here. Okay, so this is the other way of writing. Okay, this is the proof which can be derived easily from your Laplace transform properties, and all the properties. This is the second property. All the properties, whatever we discussed in Laplace, can be dealt in inverse Laplace also. So this quotes your properties of inverse Laplace. All the proof can be written by rewriting Laplace transform result and just taking inverse on both sides. Doing kind of manipulative work, you can get these results. So I'm not concentrating on that. Fine. So just recall all these results. Okay, we'll go ahead with the application of properties in inverse. Suppose you have a problem, find L inverse of 1 by s plus 3 whole power 5. See, I don't have any such formula. I have only 1 by s power n formula for inverse. So I need to remove this plus 3 parameter term and or change s plus 3 as s. So here comes the application of shifting. So shifting in inverse Laplace. So when I want to remove this, I want to replace this s plus 3 as s. Okay. So what I have to do, write a e to the power of minus 3t and find the inverse for 1 by s power 5 alone. That is what written here in this step. So now this inverse is easy, just t power 1 factor 5. So 4 by 4 factorial and conclude the answer. So that makes the work so simple if you apply the shifting property on inverse. So same shifting property can be applied here, but there is a difference because look into the second problem. You have a s minus 4 here. If I want to apply shifting, wherever I have s, I should have the same format of parametric addition. I cannot apply two formats or two constants for one single Laplace function. So this, if this is minus 4, this should also be minus 4. Only then I can apply shifting property. But it is not so. This is yes. So I have to adjust this by adding and subtracting, or subtracting and adding, whatever order we want. Then this becomes s by, because this is subtracted and added. You can always do that in mathematical logically, it's right. And now you observe that wherever I have s, it is in the s minus 4 form. So I can apply shifting property by writing minus 4. So I write e power 4t. So this s minus 4 becomes s. Just observe this. This is transformed as s. And this is also transformed as s. And s plus 4 by s square. So as we have done in the earlier case, it's a common denominator. So split and then find the value of the inverse. Okay. Fine. So third discussion. Third discussion is again some manipulating work because you have a s and s minus 1. So adjust your minus 1 plus 1. But if you adjust it here, it's not going to help. If you write it as, say if you write it as s square minus 1 plus 1, it's not going to help you write this format. So when you want to adjust s, do it for s. The powers should be in the as it is, as you have done here. Okay, so s to be written as s minus 1 plus 1. So then split in this s minus 1 terms becomes s by shifting property. I should have written an e power t. It's missing. Please do write down. Because I have written a shifting property, I should have written it here, and everywhere, even here and here, it's missed. Okay, e power t, L inverse s plus 1 by s cube. Now you expand it and then separate it to different terms, and then you can write the inverse directly. Please correct this. Put a e power t here, here it's missing here and here. Okay. So next again the difference is you have okay, this is the question, this is not the question, don't bother about this. This is the question. I have to find L inverse s by 2s plus 3 whole cube. So what I have done is I have given 1 by 8 L inverse of this. Again this 2 you should pull out. Then this, because you have a cube, it becomes 8. S plus 3 by 2. So I have to adjust a plus 3 by 2 minus 3 by 2 because I want plus in S. Again the same e power property is applied, and then you can split and write the inverse. Fine. Yes. Okay. How to handle such functions? It's a quadratic function, but it's not factorizable. As we do, if it is factorizable, I can go ahead with partial fraction, but it is not factorizable into real factors. So what we can do is we can rewrite in a quadratic form as s square. You just write s square plus 4s as s plus 2 whole square. So there will be a plus 4 added to this term, subtracted from this available. So you will be getting 16, that is written as 4 square. Just observe this step from this to this. Please do observe this to this. Both are same because s plus 4 I have written s. Okay. And now you can apply, there is no s in numerator. So just apply shifting theorem. You get this, and this is going to be your sine formula with 5 outer and 1 by 4 in the denominator. Okay. Again, this is somewhat like a adjusting problem in the quadratic factor. So do that on your own. And this is somewhat similar, adjusting some terms. So I'm just keeping it for now. I will just discuss this eighth problem. Okay, eighth problem, you have, it's not a plus, it's a product of two terms, and you have a s term also. So I cannot simply write a by b by. You can go ahead by writing partial fractions, but you can use your properties. Even this is used with the property SFS. What does that property say? But this is so easy, so this is handled this way. SFS says SFS can be written as L inverse of 1 by, you can just adjust these terms and rewrite it as, okay, this, fine, okay. So this is 1 by t, and here it goes with this. I think this should be 1 and it's not s. There is some error in the question. Okay, let it be 1. Fine. Okay. And now coming back to our partial fractions, you see this problem. where I have one linear factor and one quadratic, and this also cannot be put into linear factored form. Factorizing is not possible. So what we have to do is go ahead with your partial fraction, splitting it as a by, because this is cannot be put in factors, I write bs plus c, and compute your ABC values as we do in the partial fraction scheme, and you get your Fs this way. This is our Fs. Now to find L inverse Fs, this is not a big hurdle, but here again this has to be adjusted with some components. So here this is quadratic, so as we have done earlier, I'll write it as s plus 1 whole square plus 4. But here it is a different form, so as we do, s to be changed as s plus 1. So in this is, I am going to write it as s plus 1 minus 1. This minus is outer and this plus 2 is as it is. Then adjust this, whatever you get, group it, but don't simplify this plus 1 because we need that format. And now the second term we can apply shifting property for inverse. So this becomes, just observe the second term, e power minus t, L inverse of this. Fine. So then you split the common denominator, apply the inverse Laplace, get the result. So again, this is the property division. Yes, you can apply the 0 to t property, integrate and get the result. This is for s square, so I am applying the integral twice, and this is how we go with application of properties. And this is a specific problem where you have s power 4 minus a power 4. So it is going to be just a second. Okay, this is going to be written as s square minus a square plus a into s square plus a square, and then this appears to be our partial fraction problem. Or you can also manually guess the partial split up like this and write the result. Thank you.